Now we will study Cauchy-Euler differential equations. So the nth order Cauchy-Euler differential equation looks like this. So we have a n x to the power n dy n over dxn. So we have nth derivative. So we have x to the power n. We have n minus 1 derivative, and we have the coefficient of this derivative is a n minus 1 x to the power n minus 1, and we continue like this. So we have first derivative, then then the x, we have x in front of the first derivative, a1x dy dx plus a0y, so we don't have any derivative here and we don't have any x here, is equal to some function of x, r of x. So, and where this a0, a1 and an are constants, so we have the nth derivative, the power of x is n. Okay, let's give an example of a second order Cauchy-Euler differential equation. So we have the second derivative. What is the power of x? So we have x squared, 3x squared y double prime minus 5x y prime plus 2y is equal to some function of x. So 7e to the power x sine x. So this is a second order Cauchy-Euler differential equation. And in this lecture, we will learn how to solve this kind of equations. So, but we will focus on the second order, but the method will work for any other order. So it is always the same idea. So once a Cauchy-Euler differential equation is given, we always substitute t is equal to ln x to solve the differential equation into the given Cauchy-Euler differential equation. So when we substitute t is equal to ln x, so this reduces the differential equation into a simpler form that we know how to solve. So it will reduce it to a, who knows, maybe a homogeneous with constant coefficient differential equation, or we can solve it by using variation of parameters. So we don't know what we will get at the end when we substitute, but we know we will get something we can solve. Okay, let's see what is going on. So what we need to do, okay, maybe I will copy this part into the next page. Okay, now let's substitute t is equal to ln x. Okay, maybe I will move it. So once we substitute t is equal to ln x, so what is, okay, what is dt over dx in this case? So we know it is 1 over x, right? So what is the derivative of t with respect to x is equal to derivative of ln x with respect to x, which is 1 over x, right? So we know the derivative of ln x is 1 over of x. So what about y prime? So what are we going to put instead of y prime? So we know that y prime is equal to dy over dx. So we will use chain rule. So dy over dt times dt over dx. So this is equal to 1 over x dy over dt. So when we see y prime, we will put 1 over x dy over dt. What about the second derivative? So the second derivative, we need to d square y dx square. So, or we can write d over dx dy over dx. So we find dy over dx 1 over x dy over dt, right? So from here, and now we take its derivative. So we can think this as u times v. So we know how to take the derivative of u times v. It is u prime v plus uv prime, right? So u is equal to, let's say, 1 over x. V is equal to dy over dx. Okay, what is the derivative of 1 over x? So it is minus 1 over x squared times dy over dt plus 1 over x times d square y dt squared times. So we need to be careful. So this is the chain rule, dt over dx, right? So we need to be careful here. And so we need to remember the chain rule. So we need to take the derivative of inside. And we know dt over dx is equal to 1 over x. So we have minus 1 over x squared dy over dt plus 1 over x squared d square y over dt square. So when you see y double prime, if we take 1 over x square parentheses, so you will see d square y dt square minus dy over dt. Great. Okay. So in summary, okay, let me write what more. Okay, maybe I will write it down. So what we are going to do is we will substitute t is equal to ln x, then y prime or dy over dx is equal to, so we will put 1 over x dy over dt, and y double prime d square y dx square is equal to 1 over x square d square y dt square minus dy over dt. So we will substitute this in the equation. So substitute in the Cauchy-Euler differential equation. Okay, let me give an example. Let's do an example. It will be more clear with an example. Okay, let's do an example, and solve the given Cauchy-Euler differential equation. So it is given like this: x square y double prime minus 5xy prime plus 9y is equal to 0. As I said, so we substitute the given, let's say, second order Cauchy-Euler differential equation. But this method will work for any order, as we said. So we will substitute t is equal to ln x. Then what about dy over dx? Or we will write y prime is equal to, okay, let me, so it was 1 over x dy over dt and d square y dx square y double prime. So we will write 1 over x square d square y dt square minus dy over dt. Okay, let's substitute this one. So we have, so we now substitute in the given equation. Okay, what is the given equation? X square y double prime minus 5x y prime plus 9y is equal to 0. So we have x square. What is y double prime? It is 1 over x square d square y dt square minus dy over dt minus 5x times 1 over x dy over dt plus 9y is equal to 0. So the reason we substitute is, so the x terms will always cancel in this case. So what we are left with, d square y dt square minus dy over dt minus 5 dy over dt. So we have minus 6 dy over dt plus 9y is equal to 0. So what is this differential equation? So it is homogeneous differential equation. Homogeneous differential equations with constant coefficient. Then in this case, how we solve? So we will find the characteristic equation. What is the characteristic equation? It is lambda square minus 6 lambda plus 9 is equal to 0. And if we solve this, so this is minus minus. So we have the roots of the characteristic equation. We can find the roots of the characteristic equation, and we have repeated roots. So this is equal to 3. So we have repeated roots. Okay, we have repeated roots. So in this case, we know the solution is of this form. C1 e to the power lambda 1. So we need to be careful. I wanted to write lambda 1x, but now we are in variable dy over dt square, right? So this is lambda 1 t plus c2 t times e to the power lambda 1 t. So we should be, because t is equal to ln x, right? So we have e to the power 3t plus c2x e to c2, I did it wrong, c2t e to the power 3t. Now don't forget to substitute t is equal to ln x. Then what is the solution? C e to the power 3t ln x plus c2 ln x e to the power 3 ln x. Okay, so if you remember, when you have a times ln x, we can write ln x e to the power a, and if you have e ln x, so we know this is equal to x, right? So okay, let's simplify our equations. So we have 3 ln x cubed plus c2 ln x times ln x cubed, ln x times e to the power ln x cubed. So here, so these are equal to x cubed, right? C1, no e anymore. So C1 x cubed plus C2 ln x times x cubed. So this is the solution of the given Cauchy-Euler. Okay, I forget how to write Cauchy-Euler differential equation. Given Cauchy-Euler differential equation. Okay, do not forget to substitute t is equal to ln x back. Okay, let's solve another example. Okay, let's solve another example. Solve x square y double prime minus 4x y prime plus 6y is equal to 4x minus 6. So this is a So it is a second order Cauchy-Euler differential equation. So we will we substitute t is equal to ln x. Then what about dy over dx? So it is 1 over x dy over dt. What about the second derivative? D square y dx square. So it is 1 over x square d square y dt square minus dy over dt. So we will substitute these in the given differential equation. So we have x square y double prime minus 4x y prime plus 6y is equal to 4x minus 6. So we have x squared times 1 over x squared minus 4x 1 over x dy over dt, 4x times 1 over x dy over dt plus 6y is equal to 4x times minus 6. So we don't want any x terms. What is x? So if t is equal to ln x, then x is equal to ln t, right? Sorry, e to the power t, right? X is equal to e to the power t minus 6. Okay, do not forget the other side also. So do not forget this side. Do not forget to substitute in the other side also. Then we will cancel, x squares will cancel, x will cancel. So what we have d square y dt square minus dy over dt minus 4 dy over dt. So we have minus 5 dy over dt plus 6y is equal to 4 e to the power t minus 6. And here, so we can solve this. I mean, so this is a non-homogeneous second order differential equation. So we learned two methods. Okay, now so solve using method 1 using undetermined method of undetermined constant coefficients. So method of undetermined constant coefficients, or you can solve using variation of parameters method. So you can use any method you want. Okay, I will choose the first one because it is easier to do. Okay, so I have this differential equation. Let me write y double prime minus 5y prime plus 6y is equal to 4 e to the power t minus 6. So keep in mind that the y prime stands for dy over dt, and second derivative y double prime is d square y dt square. Okay, now we will solve using undetermined constant coefficient methods. Okay, then what is the general solution? So we know that general solution is of the form y complementary plus y particular. So what is the y complementary? So this is the complementary solution. So what is it? It is the solution of corresponding homogeneous part. So what is it? In this case, y double prime minus y prime plus 6y is equal to 0. Okay, and we know how to solve it. So we will find characteristic equation. Characteristic equation is lambda square minus 5 lambda plus 6 is equal to 0. Okay, let's find the roots. So it is, and there is a problem with the roots. Oh no. So it is minus 2 times minus 3. Okay, then we have lambda minus 2. Lambda minus 3 is equal to 0. So we are lucky. We have two distinct roots. So lambda 1 is equal to 2. Lambda 2 is equal to 3. So these two distinct roots. Then what is the complementary solution? So it is c1 e to the power. You may say lambda 1x, but be careful because we are now in variable t. So lambda 1 t, c2 e to the power lambda 2 t. Then y complementary is c1 e to the power 2t. You see, I write x. Funny. E t 3t. So now we will find y particular. So to find particular solution, y particular, we will check. If you remember, we were always checking this part. So in this case, we have RT, so not R of x. So RT is 4 e to the power t minus 6. So we may guess. So if this is it a part of the complementary solution or not? So this is not a part. Y complementary or not contained in Y complementary. Also this one. So this is not contained in Y complementary. So our guess will be it is a times e to the power t plus b. So for 6 we write b, and this is our guess. So if this part is contained in the complementary solution, don't forget to multiply with t, right? So we learned this method. Okay, now we need to find a and b. Substitute in the equation. Okay, what is our equation? But we need to substitute in this y double prime minus 5 y prime plus 6y is equal to 4 e to the power t minus 6. Okay, we will substitute in this one, but we need to find the derivative first. Y prime is e to the power at, but we are lucky, so this is also e to the power t. Okay, y double prime a e to the power t minus 5a e to the power t plus 6a e to the power t plus b is equal to 4 e to the power t minus 6. So here, okay, let's see. 7a minus 5a, so 2a e to the power t plus 6b is equal to 4 e to the power t minus 6. So here 2a is equal to 4, 6b is equal to minus 6, a is equal to 2, b is equal to minus 1. So what is the particular solution? A e to the power t plus b, 2 e to the power t minus 1 is the particular solution. What is our complementary solution? It is this one. And then what is the general solution? So y general is y complementary plus y particular. So it is c1 e to the power 2t plus c2 e to the power 3t plus 2 e to the power t minus 1. So this is our general solution. Okay, let me cut it here. Okay. So this is the general solution. Okay, but we are not done yet because we need to substitute t back. So, but we are not done. Okay, I was trying. Okay, we are not done. So substitute t is equal to ln x back, or so if and only if x is equal to e to the power t. We can do that also, or so what is the general solution? Sorry, I write here y general. Y general is c1 2 ln x plus c2 e to the power 3 ln x plus 2 e to the power ln x minus 1. So c1 e to the power ln x squared plus c2 e to the power ln x cubed plus 2 ln, e to the power ln x minus 1. So we know that e to the power ln something, whatever inside is equal to e inside. So e to the power ln x is equal to x, or e to the power ln x squared is equal to x squared. Then y general is c1 x squared plus c2 x cubed plus 2x minus 1. So this is our general solution of the given Cauchy-Euler differential equation. So I think this is it.